Hello, this is Marcus Lee, and today I'll be doing YLOC Lesson 24 for 7th grade math. Okay, so our directions are to graph the quadratic function, and so this example number 2 right here will begin. We're given y equals parentheses x plus 5 times parentheses x plus 2. And when we're given quadratic functions or equations in general, this is what's known as factored form, in which both factors are written in parentheses. So what these factors tell us they tell us these are considered zeros. And basically they tell us where the graph will intercept the x-axis. So x-intercepts. They're basically, our zeros are the same thing as x-intercepts. So it's telling us where the graph of this function will cross this this x-axis line. So to find out our zeros, we just set the function equal to 0, and we have 0 equals x plus 5 and x plus 2. So if we've learned that we could set each factor equal to 0, we'll get x equals negative 5 and x equals negative 2. Sorry, it's kind of hard to fit it in here, but negative 5 and negative 2 are x-intercepts or are zeros. So basically that's where they will cross the x-axis. So if this graph is in scale of 1, then this here is negative 2 and here is negative 5. And what you want to do to fill in the rest of the points is just make an XY chart. So we know that negative 5 is 0 and negative 2 is 0, so we could plug in values into our original equation. For example, we could plug in negative 4 into this equation and we will get I'll just do it in blue here. Negative 4 plus 5 times negative 4 plus 2. And that will be negative 1 times negative 2, which is positive 2. Same thing here. We could do negative 3 and negative 3, which will yield, oh, this is actually negative 2. Whoops. This is 1, positive 1 times negative 2, which is negative 2. 3, or negative 3 here is positive 2 times negative 1, which is also negative 2. Negative 1 should be 4 times 1, which is 4. And 0 should be 10. So if we plot those points on our graph, we have negative 3 comma negative 2 and negative 4 comma negative 2 and negative 1 comma 4. 1, 2, 3, 4 right here. And quadratic functions that look like this are mirrored. So basically, when we have our points like this, we could draw our curve. This isn't going to be the most perfect curve, but hopefully you get the idea. So that's what our graph of number 2 will look like. So we're not going to have too much time, so I'm just going to go on to this next page. Solve the equation by graphing. So we're given x squared minus 2x equals 3. What we want to do is move 3 over to the other side and set the whole equation to 0. And then we want to factor. So this will be x minus 2, or x minus 3, x plus 1 equals 0. So our zeros are going to be x equals 3 and x equals negative 1. So we know that the graph will cross the x-axis at 3, 1, 2, 3, and negative 1. And then we want to do our XY chart again. So we have negative 1 here and 3 here, so these are both 0. You don't have to plug in all these values, but doing as many as you can to make sure you're correct is always pretty helpful. So this will be -3. This is going to be -2 times 2, -4. This is going to be -3. And 4 will be 5, I think. 5. So we have 0, comma, -3, 1, 2, 3. Here, here, and then 1, 2, 3, 4, 5. There we go. And once again, the curve's not going to be the greatest. Oh, that point's supposed to be here. Whoops. Right here. There we go. There we go. And that's what our graph looks like. So in that situation, you just want to factor after moving the things over. Okay, next one, we have another one where you just factor it. We have x squared plus x minus 6 equals 0. When we factor this properly, we get x plus 3 and x minus 2 is equal to 0. And we get x, our zeros are x equals -3 and x equals +2. So +2 is right here, -3 is 1, 2, -3 right here. And then we want to do our xy graph again, or xy chart. And when this is all figured out, it should come to 2, 3. We have 0 here and 0 here. So if we test -2, we get 1 times -4. I think. Same thing here, -4. Then 0 should be -6, and so is 1, -6. Okay. So -2 should be -4, 1, 2, 3, 4. -6, -6, -4, and then we could draw a curve. And then, unless there are restrictions on the domain, which we haven't learned yet, we always want to put our arrows on these graphs, on the ends of your graphs, to indicate that it goes on forever. And last problem, it's the same concept. We have x squared minus 6x plus 9 is equal to 0. So this one will be x minus 3, x minus 3 equal to 0. And you'll realize that we only have one 0. So x minus 3 times itself is essentially x minus 3, the quantity squared, equals 0. And what that tells us is that depending on which direction our quadratic function opens up or down, if it opens this way or this way, it's still going to be a 0 or an x-intercept, because it will touch the x-axis, but since we have this squared here, it's not going to pass through. It's going to like kind of bounce off like that. So it's not essential to know that, but we could always, if we're confused, make our chart. So 2, 1, 4, 5. And this one should be 4 and 4. Okay, there we go. So we have 3, 0, 2, comma 1, which is right here, 4, comma 1, which is right here, 5, comma 4, and 1, comma 4. 1, 2, 3, 4. Right here, and then we could draw our curve. Then always put your arrows on the end unless there's restrictions, and otherwise that's what your quadratic function is going to look like. I assume in later videos we're going to learn about leading coefficients and negatives and other reflections or transformations to graphs, but that was lesson 24 for today. I hope this was helpful, and thank you for watching.